You think you understand what big means, until the universe smiles and gently proves that every human comparison is nothing more than a grain of dust drifting through starlight. There are galaxies that do not simply grow large, they swallow the very idea of size, bend imagination, and make time itself feel as fragile as a single breath. This video is a promise, not dry numbers, but awe, reverence, and a quiet moment of silence before the infinite. Leave a comment below. What makes you feel smallest when you think about the universe? And now, walk with me into the first chapter, when big no longer has meaning. Have you ever noticed how the word big feels solid in your mouth, right up until the universe asks you to use it honestly? When we say a large galaxy, we're not really speaking the language of space. We're translating the unknown into something domestic, something our nervous system can tolerate. We borrow the only measuring stick we truly own, the scale of our bodies, our houses, our commutes, our lifetimes. We know what it means for a building to be tall because we can stand at its base and tilt our heads until our neck complains. We know what it means for an ocean to be wide because we can stare at the horizon and feel the gentle insult of distance. But a galaxy does not offer us a shoreline. It does not give us a corner to turn, a path to walk, a summit to climb. It is not big the way a mountain is big. It is big the way memory is big, the way deep time is big, the way a dream can contain an entire childhood in a handful of seconds. So what are we comparing it to, really? Most of the time, we compare it to the one galaxy we live inside, the Milky Way, because familiarity is the mind's favorite shortcut. The Milky Way becomes our hometown. It becomes our baseline. It's the comforting illusion that if we can picture our own spiral, then we can picture others. But the Milky Way is not a standard unit handed down by nature. It's an accident of where we happen to be born. And the moment you meet a galaxy that dwarfs it, the comparison stops being helpful and starts becoming an event, like a door opening in a room you did not know existed. This is where the limits of the human brain quietly reveal themselves, not as a failure, but as a design choice. Your mind was not built to visualize a million light years the way it visualizes a mile. It evolved to keep you alive between the next meal and the next storm, between the next shelter and the next threat. We are brilliant at mid-range reality. We can throw a ball, read a face, sense a lie, remember a path through the woods. But astronomical numbers live outside the territory our instincts map. They are too large, too indifferent, too patient. And so the brain does what it always does when confronted by the ungraspable. It compresses. It turns infinity into a word. It turns billions into a blur. It replaces comprehension with recognition, the feeling of, "I've heard that," which is not the same as understanding. There is a reason a number like 1,000 feels like a crowd, and a number like 1 billion feels like a statistic. Between them is not just arithmetic. Between them is a canyon in human intuition. The mind can count stones in a pouch, it can count days in a season, but it cannot feel a billion in its bones. And galaxies ask you to feel what you cannot feel, to hold what you cannot hold, to imagine a structure so vast that even the light inside it spends lifetimes crossing from one shore of stars to the other. This is why large galaxy is not only a physical description, it is a psychological confrontation, because scale is never only about size, it is also about the observer. A galaxy's diameter can be measured, yes, but the meaning of that measurement depends on what kind of creature is doing the measuring. For a civilization with a lifespan of centuries, a million-year crossing time might feel like a slow walk. For us, it is a kind of eternity. That's why the word large is secretly two words braided together, the objective and the subjective. There is the galaxy itself, and there is what the galaxy does to the mind looking at it. In that sense, scale becomes a mirror. It reflects the shape of our consciousness, the edges of our imagination, the places where language begins to stutter. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." And the incredible thing, very often, is not an exotic object, not a spectacular explosion, not a strange signal, but the sheer fact of proportion, the way the universe refuses to fit inside our ordinary categories. And when you feel that refusal, when you realize that your best metaphors are still too small, you begin to sense why people describe astronomy as humbling, not humiliating. Humbling. It returns you to a more accurate relationship with reality. Here is one simple example, a small ladder for the mind. Imagine the Earth as a peppercorn, not a marble, not a basketball, but a peppercorn, something you could lose between the folds of your fingers. At that scale, the moon is a pinhead about a foot away. The sun, that furnace that rules our days and warms our skin, becomes a sphere roughly the size of a beach ball placed several yards away. Already, the room begins to feel strange. Already, the distances stretch. Now keep going. The nearest star would be thousands of miles away at that same scale. Not across the room, not across the street, across a continent. And that's just the beginning. This is what galaxies do to our intuition. They take the cozy model our brain tries to build, and they tear the walls down until your imagination is standing in open air. A second example brings the lesson closer to home. Think of time the way you think of money. 1,000 seconds is about 16 minutes. 1,000,000 seconds is about 11.5 days. 1,000,000,000 seconds is more than 31 years. The numbers look like siblings on a page, but in lived experience they are strangers. Now apply that same emotional jump to distance, to mass, to the number of stars in a galaxy, to the number of galaxies in the observable universe. You begin to see why the brain hits a limit. The issue isn't intelligence. The issue is embodiment. We are not built to inhabit scales that dwarf our entire species' story. We can measure them with instruments and mathematics, but to imagine them with feeling, we must build new inner muscles. And that takes time, repetition, and a willingness to be uncomfortable. So when you ask whether scale is only a physical measurement or also a measurement of perception, the answer is hiding in your own reactions. Notice what happens when you hear that a galaxy can be hundreds of thousands of light years wide, or even more. Do you picture something definite? Or do you picture a vague, luminous smear labeled huge in the corner of your mind? That smear is not ignorance. It is your brain's protective fog. It is the same fog that keeps you from being overwhelmed by the enormity of your own life. The number of moments you have lived without remembering, the number of steps you have taken without counting. The mind edits reality, not to lie, but to function. And yet, the universe invites us to step beyond that edit. It invites us to practice a larger honesty. Because if everything is larger than we assumed, then some of our long-held ideas have been quietly shaped by convenience. We tend to imagine ourselves near the center of whatever story we're telling. We tend to imagine our galaxy as a meaningful reference point, our neighborhood of space as typical, our cosmic environment as representative. But the more we learn, the more we see that typical is a dangerous word in a universe this vast. It may be that the Milky Way is neither especially large nor especially small. It may be that our local cosmic architecture is not the norm. It may be that the things we take for granted are local accents in a language spoken differently elsewhere. And this is where the educational value deepens. The true lesson of scale is not that the universe is big. You already knew that. The lesson is that human certainty shrinks when confronted with proper context. And that shrinking is not a loss. It's a refinement. It teaches us to hold our theories more gently, to leave space for revision, to let curiosity outrank pride. Neil deGrasse Tyson captured this spirit with a line that has the clarity of a bell in the dark. The universe is under no obligation to make sense to you. Not cruelly, not dismissively, simply truthfully. The universe does not adapt itself to our preferred story. We are the ones who must learn to adapt our minds to its scale. There is something quietly meditative about this, if you let it be. When you contemplate a galaxy so large that its outer stars feel like distant villages from the perspective of its own core, you begin to sense the difference between information and wisdom. Information tells you the number. Wisdom tells you what the number does to your place in the world. It steadies your emotions. It softens the frantic importance we attach to small dramas. It does not erase meaning. It relocates meaning. It reminds you that your life is precious not because it is large, but because it is brief, luminous, and aware. And as we move from the familiar into the truly immense, you might notice a subtle shift inside yourself. At first, the mind resists. It wants the universe to fit into a picture. It wants scale to be a diagram. But if you stay with it, if you keep listening, something else becomes possible. The mind begins to treat scale not as a wall, but as a doorway. Not as a threat, but as an invitation. The cosmos stops being a place out there and becomes a context all around. You are not merely learning about galaxies. You are learning about the limits of your own perspective, and that is one of the most valuable forms of education there is. And so, if we've been wrong, where have we been wrong? Not in our measurements, necessarily, but in our instinctive assumptions about what those measurements mean. We have been wrong whenever we confuse the ability to say a number with the ability to truly imagine it. We have been wrong whenever we treat our local environment as the default for the cosmos. We have been wrong whenever we think the universe owes us comfort. The correction is not despair. The correction is awe, disciplined by humility, guided by curiosity, which brings us, naturally, almost inevitably, to the first threshold in this journey, the moment where language begins to fail and perception must take over. Because the next step is not to chase a bigger statistic, but to stand at the edge of comprehension and watch the mind stretch. In the next part, we enter the place where the word big breaks apart in your hands, where comparison becomes useless, and where you begin to feel, rather than merely know, what scale truly means. We are about to cross into that chapter now, the one that changes the way every later number will sound in your ears, the one that sets the entire journey in motion, the one called, quietly and truthfully, when big no longer has meaning. Have you ever noticed how the word large feels perfectly confident right up until the moment you try to define it? For a long time, the Milky Way wore the crown of enormity in the human imagination, not because it was truly the largest, but because it was the largest thing our instruments, our methods, and our minds could honestly hold at once. We judged the cosmos the way sailors once judged oceans, by the reach of their lanterns, by the stubborn boundary of fog, by what could be felt with a hand on a rope and a compass needle trembling in the dark. In the early days of astronomy, the Milky Way was not simply a galaxy. It was the universe, or at least the best version of the universe that could be drawn from the evidence available. Through small telescopes and even smaller assumptions, those faint, misty nebulae scattered across the sky looked like local weather clouds in our own celestial backyard. When you cannot measure distance well, everything becomes intimate. When you cannot resolve individual stars, everything becomes conveniently nearby. The Milky Way, luminous and sprawling across the night, seemed not only huge, but total, a complete kingdom of stars with no rival visible beyond its borders. And so our species did what it always does in the face of the unknown. We wrapped a circle around what we could see and called it reality. This is not a failure of intelligence. It is a portrait of how knowledge is born. A standard is not chosen because it is perfect, but because it is available. And the Milky Way was available in the most literal sense overhead, every clear night. A river of starlight spilling across the dark like a memory we couldn't quite translate into words. For centuries, we mapped its shape from the inside, which is like trying to understand the size of a forest while standing beneath its canopy at midnight. You can count nearby trunks. You can smell sap and damp soil. You can hear the wind comb through leaves. But the forest's true outline remains hidden until you step back far enough to see the whole. Yet stepping back is not a poetic gesture. It requires new tools, new mathematics, new patience, and most difficult of all, a willingness to admit that the comfortable picture might be wrong. That willingness did not arrive in one dramatic revelation, but in a slow rearranging of humility. Methods improved. Distances became measurable through subtle rhythms, the pulse of Cepheid variable stars, the steady light of standard candles, the calibrated ladder of cosmic measurement. And then, almost quietly, the universe changed size. Those nebulae ceased to be local smudges and revealed themselves as island universes, galaxies in their own right, far beyond the Milky Way, each one a city of suns separated from us by oceans of darkness. In that moment, the Milky Way didn't shrink. Our perspective expanded. The crown remained beautiful, but it was no longer solitary. There is a sentence often attributed to Edwin Hubble that carries the mood of that turning point. Equipped with his 5 senses, man explores the universe around him and calls the adventure science. It sounds simple, almost gentle, but it hides a hard truth. Our senses, extended by mirrors and detectors and algorithms, do not reveal the universe all at once. They reveal it in slices. And when the slice is narrow, the story is narrow. When the slice widens, old certainty becomes a temporary draft. This is where the danger of a too small standard begins. A standard is like a ruler. If your ruler is only a few inches long, you can still measure a road technically, but you will do it in 1,000 awkward steps, and you may never notice that the road extends beyond the map you trust. In cosmic terms, if your ruler is the Milky Way as the biggest meaningful structure, then everything else is interpreted through that lens. Galaxies must be smaller, the universe must be bounded, the distant must be local, the unfamiliar must be familiar. The problem is not that you are wrong about the numbers. The problem is that you are wrong about what questions are worth asking. A too small standard quietly forbids certain possibilities. It turns vastness into an error bar. It makes the unknown feel like a rounding mistake rather than a doorway. Think of it like this. Imagine you live in a valley where the horizon is always a ring of mountains. Day after day, the sky ends at stone. Clouds rise, birds cross, seasons turn, and the mountains remain, solid as certainty. It would be natural to assume that beyond the mountains there is more of the same, more ridges, more familiar slopes, perhaps another valley much like yours. Now imagine, one day, you climb high enough to see that the mountains are not the boundary of the world at all. They are the rim of a crater. Beyond them lies an ocean so large it changes the meaning of distance. Your valley does not become smaller, but your assumptions about the world do. This is one of the simplest examples of how standards mislead, not by lying, but by limiting what you consider possible. Or take a second example, closer to the daily life of anyone who has ever tried to explain scale to a child. Picture a person standing at the edge of a city at night, looking at the skyline. If that city is all they know, those towers feel like the maximum expression of tall. Then they travel, they see a mountain range. Suddenly, the skyline is still impressive, but it no longer defines tallness. Now imagine they travel again, and they see Earth from orbit, a blue sphere with a thin atmosphere like a breath on glass. The mountains become textures. The skyline becomes invisible. Nothing has changed except the reference point. And yet everything changes. Meaning, proportion, certainty. This is what happened to us with the Milky Way. We mistook the skyline for the planet. So yes, discoveries were delayed, and not because scientists lacked brilliance, but because the frame of comparison was quietly miscalibrated. When you assume the Milky Way is the entire universe, the question, how many galaxies exist, does not even appear. When you assume those distant smudges are nearby clouds, you do not build the instruments and methods needed to measure them as separate worlds. When you think your home is the whole map, you don't look for roads that lead elsewhere. The history of science is full of these delayed revelations, moments when progress waited not on new data, but on a new willingness to interpret the data differently. And here the story becomes more than astronomy. It becomes a meditation on the psychology of knowing. Because the question is not only why the Milky Way was once considered large. The deeper question is what happens inside the human mind when a standard becomes emotionally comfortable. The Milky Way as the big one was not merely a scientific idea, it was a cultural shelter. It offered a universe we could imagine, a single grand structure with us somewhere inside it, significant by proximity. To discover that the Milky Way is one among hundreds of billions of galaxies is not just to add a fact. It is to loosen a grip. It asks you to live with a more honest kind of smallness. Carl Sagan, who understood better than most how to translate cosmic facts into human feeling, once said, "Somewhere, something incredible is waiting to be known." That line is often repeated, but its real power is not optimism, it is discipline. It is a reminder that the incredible is often invisible to us, not because it is hidden, but because our expectations are too cramped to recognize it. The incredible waits at the edge of our assumptions, where the mind resists and curiosity insists. This brings us to your sharpest question. In science, what is more dangerous, not knowing or believing you know enough? Not knowing can be painful, but it is honest. It leaves space for questions, for doubt, for the healthy discomfort that drives investigation forward. Believing you know enough is quieter and far more seductive. It turns curiosity into a museum, beautifully arranged, carefully labeled, and fundamentally closed. When we believe our standard is complete, we stop looking for better standards. We stop testing the edges. We stop being surprised, and surprise is often the first symptom of truth arriving. The Milky Way, once the largest, teaches us this lesson without cruelty. It does not mock us, it simply continues to exist, serene and indifferent, while our understanding matures around it. It reminds us that knowledge is not a destination but an expanding horizon. Today, we talk about supergiant galaxies, galactic clusters, and filaments of large-scale structure that stretch across unimaginable distances, and we do so with a confidence built on better tools and deeper evidence. But if the past teaches anything, it is that our current standards may also be provisional. There may be structures larger than we suspect, patterns we cannot yet see, truths waiting in the faint light beyond our present reach. And this is where the narrative becomes gently spiritual, not in the sense of doctrine, but in the sense of awe. Because every time our standard expands, we are invited to become a little quieter inside, to replace arrogance with attentiveness, to trade the comfort of completion for the dignity of searching. The universe is vast, yes, but the real transformation happens in the mind that tries to meet it honestly. So when you ask why the Milky Way was once considered large, you are really asking how a species learns. You are asking how we build ladders out of limited information, how we climb, how we discover that the ceiling was only a low cloud. And when you ask what happens when our first standard is too small, you are asking how many truths remain invisible simply because we have not yet invented the right way to compare them. When you ask how many discoveries were delayed by comparing wrong, you are not condemning the past, you are protecting the future. You are reminding us to keep our standards flexible, to treat certainty as a tool rather than a throne. And now, with that lesson held softly in mind, we can move forward without breaking the spell. Because the Milky Way was only the beginning of our scale problem. Once you accept that your home galaxy is not the largest thing, you are forced into a new kind of question, one that feels almost like standing at the edge of a quiet abyss and listening for an echo. If this is not the biggest, then what is? And more importantly, what does biggest even mean in a universe that keeps rewriting the meaning of size? Let's take that breath together and step into what comes next, the moment when large becomes inadequate, and the cosmos begins to show us structures so immense that the imagination has to evolve just to follow. What does it mean for something to be the largest, when the very word begins to dissolve the moment you try to hold it in your mind? Imagine standing at the edge of a quiet night, the air cool, the world asleep, and asking a single question into the darkness. What kind of object could make our own Milky Way feel like a small hometown on an endless map? That question is the doorway to IC 1101, a name that sounds almost clinical, like a label on a museum drawer, yet it points to something so vast that it can rearrange the way you think about scale itself. IC 1101 is unusual not because it is simply big, but because it is big in the particular way only the universe can be big. Layered, accumulated, grown from countless histories pressing into one another. It is often described as a supergiant elliptical galaxy, and that phrase matters. Spiral galaxies like our own carry a kind of graceful order, arms curving like a slow dance around a bright center. Ellipticals, especially the largest ones, feel different. They are less like a single spinning story, and more like an archive, a dense, ancient city of stars built from mergers, collisions, and quiet captures over unimaginable time. IC 1101 sits where galaxies gather in a rich cluster environment, and some astronomers have described its class of galaxy as the kind that seems to dominate its neighborhood the way a mountain dominates a landscape. If the Milky Way is a bright campfire in a forest clearing, IC 1101 is the entire range of hills behind it, dark and immense, quietly shaping everything nearby. So how can a galaxy stretch across millions of light years? The honest answer begins with a humbler truth. It does not do it all at once, and it does not do it alone. Galaxies grow the way coastlines grow, the way coral reefs grow, the way memory grows inside a human mind. Not by leaping from small to vast in a single motion, but by collecting, absorbing, rearranging. Over cosmic time, Smaller galaxies drift in, fall in, and are pulled apart by tidal forces, their stars becoming part of a larger system. In clusters, where gravity has had billions of years to organize matter into crowded neighborhoods, this process can become relentless. A large central galaxy can develop an extended halo, a faint sea of stars that reaches far beyond what the eye would call a clean edge. In other words, part of the size is not a sharp boundary but a gradual fading, the galaxy's outskirts thinning into darkness like breath into cold air. This is where the mind begins to slip. We like edges. We like the clean circle around a thing we can name. But IC 1101, like many of the largest galaxies, challenges that instinct. Its enormity is not just a matter of diameter in the everyday sense, but of how far its light and its gravitational influence extend through space. The stars in its outer regions can be so faint and so dispersed that calling them the edge feels like pointing at mist and insisting it is a wall. And yet, that faintness is part of the lesson. The universe does not always build its greatest structures with sharp lines. Often, it builds them the way it builds meaning. By gradients, by whispers, by transitions so slow that only patience reveals them. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." In the case of IC 1101, what is waiting is not just a fact, but a feeling. The moment you realize that incredible is not a metaphor, it is literal. A light year is already a concept designed to stretch the human mind. The distance light travels in a year, racing at a speed so absolute it has become a law of reality. Multiply that by 1,000,000, and you are no longer in the realm of ordinary imagination. You are in a realm where language becomes an approximation, and wonder becomes a kind of honest response. Now consider the question people always ask next, because it is the only way we know to make scale feel real. How many Milky Ways could fit inside it? The number depends on which estimate of IC 1101's size you use, because measuring the outskirts of such a galaxy is like measuring the reach of a shadow in fog. But even conservative comparisons can be startling. The Milky Way is roughly 100,000 light-years across in its bright disk, and its halo extends farther. IC 1101 is discussed in terms that can reach into the millions of light-years across when including its vast envelope. If you compare the bright, familiar scale of the Milky Way to those larger estimates, you can end up with a mental image of many dozens, even hundreds, of Milky Way disks laid side by side across that span. It is not that IC 1101 is a neat container waiting to be filled with copies of our galaxy like marbles in a jar. It is that the yardstick you have trusted, the Milky Way, begins to look like a single word in a library. Here is the first example to make it tangible, not as a number, but as a sensation. Imagine you are holding a small coin in your hand, and that coin represents the Milky Way. You can see its face, its edges, its shine. Now imagine the largest sports stadium you have ever seen, not the field alone, but the entire structure. Stands, corridors, lights, parking lots, the whole footprint. Let that stadium represent IC 1101. The coin is not small in a mocking way. The coin is still a galaxy, still hundreds of billions of stars, still a cathedral of matter and time. Yet placed beside the stadium, the coin becomes something else, not diminished in value but repositioned in context. This is what cosmic scale does. It does not insult you, it instructs you. And here is the second example, quieter, more intimate. Think of a single human lifetime, from childhood to old age, and imagine it as one evening's walk along a shoreline. You step onto the sand, you walk, you turn back, you return home. Now imagine the timescales that help build a galaxy like IC 1101 as the slow movement of continents beneath the ocean, the deep geological choreography that reshapes the planet while generations live and vanish without noticing. That is closer to the truth. A supergiant galaxy is not merely large, it is ancient in a way that dwarfs our calendar. It has had time to be assembled by the universe's patient hands, piece by piece, merger by merger, like a quilt stitched from countless histories of star formation and gravitational capture. So what collapses inside the human mind when we make this comparison honestly? At first, it is the illusion of intuitive scale. We live in a world where distance can be walked, driven, flown. Even the largest earthly distances still belong to a human map. But IC 1101 belongs to a different category of reality, where distance is no longer a matter of travel, but of light itself, where even the idea of crossing becomes absurd. When you truly feel that, something in you gives way, the expectation that the universe should be built to match the shape of human understanding. Then a second collapse follows, subtler, the collapse of centrality. The Milky Way is home. It is the galaxy we name without thinking, the one we picture when we hear the word galaxy. For a long time, humanity lived with a comforting assumption that our neighborhood might be typical, or at least comfortably significant. But an object like IC 1101 whispers a different story. It does not say we are unimportant, not in any cruel sense. It says we are not the measure. There is a difference. One is despair, the other is freedom. When you stop demanding that reality orbit your intuition, you gain the ability to learn from what reality actually is. And then a third collapse, perhaps the most educational of all, the collapse of simplicity. People often imagine that the biggest things must be the most obvious things. Surely a galaxy that large would be a blazing beacon, impossible to miss. Yet many of these giants reveal themselves through careful observation, through subtle measurements, through patient study of faint light at the edge of detection. The largest structures can be quiet. They can be diffuse. They can hide in plain sight. The universe does not always shout its greatest truths. Sometimes it murmurs them in wavelengths our eyes cannot see. This is where the story becomes more than astronomy, because the pattern repeats in human life. The most important forces that shape us are not always the loudest. Time, memory, habit, gravity, grief, love, curiosity, these are not always dramatic, but they are immense. And in the cosmic mirror of a galaxy like IC 1101, we are reminded that magnitude can be gentle, that influence can be subtle, that the biggest realities may be the ones we learn to perceive with patience. Stephen Hawking offered a line that, in a strange way, fits perfectly here. Remember to look up at the stars and not down at your feet. It sounds like simple advice, almost like a greeting card. But when you place it beside IC 1101, it becomes something deeper. Looking up is not only a direction, it is a discipline. It is the willingness to let your mind be stretched, to let your assumptions be reshaped, to let the universe educate you without humiliation. And what does that education look like when it is absorbed rather than announced? It looks like humility that does not shrink you, but steadies you. It looks like a renewed respect for evidence, for measurement, for the careful work required to describe reality. It looks like an emotional recalibration. The problems of a day may still be real, still painful, still worth addressing, but they no longer pretend to be the whole story. The cosmos does not erase your life. It frames it. And framing can be a kind of healing. Now, as we move forward, notice what has happened already. We began with a name, IC 1101, and within moments, we were forced to confront the limits of our mental tools. We tried to picture millions of light years, and our imagination reached for metaphors because numbers alone could not carry the weight. This is not a failure of the human mind. It is a sign that you are using your mind honestly. Awe is not confusion. Awe is accuracy. The emotional recognition that you have encountered something larger than your internal map. And that brings us to the most important transition, the hinge that connects this moment to everything that follows. If IC 1101 makes the word big feel inadequate, then we must ask what we really mean when we use size as a concept at all. Are we talking about diameter, mass, brightness, halo, gravitational reach, history, influence? The universe is about to teach us that scale is not a single number, but a layered reality, and that the most profound kind of understanding is not memorizing the largest measurement, but recognizing why your mind resists it, and how that resistance can be transformed into wonder. So let's step gently into the next part of the journey, because we have arrived at the threshold where language begins to tremble. We are about to enter the place where big stops behaving like a word you understand, and starts behaving like a doorway into something almost spiritual in its vastness. The moment when the universe asks you, quietly and without judgment, whether you are ready to let go of your smallest definitions. Have you ever noticed how the biggest things in the universe rarely look neat, symmetrical, or finished, as if the cosmos, when it builds on a truly colossal scale, abandons perfection and chooses something wilder, something more alive? That question sits at the heart of these galactic giants, because the largest galaxies we know are often the least tidy, their stars swirling in multiple directions, their halos stretching like fog into the dark, their cores layered with the remnants of older lives. We grow up with the quiet idea that bigger should mean more complete, more refined, more stable, like a cathedral that gains elegance as its walls rise higher. But the universe does not build cathedrals. It builds coastlines. And coastlines are beautiful precisely because they are irregular, carved by time, shaped by storms, and endlessly rewritten by the sea. When we look at the most massive galaxies, especially the giant ellipticals that sit at the centers of galaxy clusters, we are not seeing a single coherent object that grew calmly from a seed. We are seeing a history, and history is never smooth. It is layered, interrupted, and full of collisions that left fingerprints in starlight. It helps to begin with a simple shift in perspective. A galaxy is not a statue. It is a crowd in motion. Hundreds of billions of stars, plus gas, plus dust, plus dark matter, all moving under gravity, all responding to influences that stretch far beyond the visible edge. The larger a galaxy becomes, the more it is exposed to the universe around it, like a great ship that cannot hide from the weather because its sails are too wide, its hull too deep, its journey too long. On small scales, gravity can sculpt order. On huge scales, gravity invites company, and company invites complication. A massive galaxy does not grow in solitude. It grows at the busiest crossroads of the cosmic web, where filaments of matter funnel smaller systems inward, where clusters form, where everything is falling toward everything else, slowly, relentlessly, for billions of years. In that environment, chaos is not a failure of design. It is the signature of growth. This is where time and violence become inseparable, not as opposites, but as partners. We often speak of time as gentle, patient, almost kind, as if enough years will polish rough edges into smooth truths. Yet cosmic time is not simply a long, quiet night. It is a long night with thunderstorms. The question, then, is not whether size comes from time or from violence, but how time expresses itself through violence at the scale of galaxies. Because in the universe, a collision does not always mean destruction. Often, it means construction. Two galaxies can meet like two slow-moving ghosts, passing through one another's star fields without most stars ever touching, and yet the gravitational encounter can still be catastrophic for structure. Orbits are scrambled, gas clouds are compressed, star formation flares like sudden fire. Tails of stars are thrown out like ribbons into intergalactic space. And in the aftermath, the original spiral elegance can dissolve into something rounder, thicker, and more complex, like a memory that has been rearranged by emotion. One of the most sobering truths is that the largest galaxies are often the end products of many mergers. Not one dramatic event, but an accumulation. A kind of cosmic archaeology. Each merger adds mass, yes, but it also adds disorder. It introduces new orbital directions, new populations of stars with different ages and chemical signatures, new globular clusters, and sometimes new black holes that will eventually spiral together at the center. Over time, the galaxy becomes less like a single story and more like a library where many stories have been shelved together, some torn, some rewritten, some half-burned at the edges. If you could stand inside such a galaxy and watch it over billions of years, you would not see a clean narrative arc. You would see arrivals. You would see disruptions. You would see periods of calm followed by sudden upheavals. You would see the galaxy becoming vast and in the same breath becoming complicated. Carl Sagan once offered a line that feels like a lantern in this darkness. We are a way for the cosmos to know itself. That is not a claim of certainty. It is a poetic recognition that when we study the universe, we are studying something that produced minds capable of wonder. And wonder deepens when we realize that the largest galaxies may be telling us something about the cost of becoming immense. They are not simply big. They are experienced. They have survived environments where smaller galaxies are harassed, stripped of gas, and sometimes torn apart. In dense clusters, the space between galaxies is not empty in the way our intuition imagines. It is filled with hot plasma, gravitational tides, and constant motion. A galaxy that grows to monstrous size in such a place does so by enduring, by absorbing, by being shaped again and again by forces that do not care about aesthetic simplicity. If you want an image that makes this easier to feel, think of a calm spiral galaxy, like a pinwheel of light, and then picture what happens when two such pinwheels drift toward each other over hundreds of millions of years. This is not a car crash. It is more like two weather systems colliding, two hurricanes intertwining, each reshaping the other's winds. The antennae galaxies are a famous example of this kind of encounter, where long arcs of stars stretch outward like thrown strands, and regions of intense starbirth flare where gas has been compressed. It is messy, luminous, and transitional. Now imagine that not once, but repeatedly, across cosmic time, especially near the center of a cluster where galaxies are abundant and relative speeds are high. The result will not be a pristine spiral. The result will be something broader, rounder, and more dynamically mixed, a giant elliptical whose outer halo is a faint ocean of stars, many of which were not born there, but were gathered. A second example can be even closer to home, because it involves our own future in the distant sense, the way the night sky contains not just what is, but what will be. The Milky Way and Andromeda are on a slow collision course, expected to merge billions of years from now. When people hear collision, they imagine impact, explosion, shards. Yet the more accurate image is a long gravitational embrace, where the spiral structures distort, stars are redistributed into new orbits, and over time, the combined system may settle into a more elliptical shape. The important point is not the spectacle, but the lesson. Even the galaxy we call home is not a finished object. It is a participant in an ongoing cosmic dance. And if our relatively modest galaxy will one day be reshaped by merger, then the largest galaxies, which have likely experienced many such dances, should full well look like layered, complicated consequences. So when you ask why the biggest galaxies are often chaotic and complex, you are really asking why the universe's greatest monuments look more like ruins than palaces. And the answer, gently, is that they are not monuments in the human sense. They are living accumulations. They are the surviving centers of gravitational ecosystems. Their messiness is the fossil record of their growth. In a spiral galaxy, order is maintained by a kind of rotational choreography. Stars orbit in broadly similar planes, and the disk can preserve patterns that feel legible to us. In a giant elliptical, especially one at a cluster's heart, the orbits are more randomized, like a stirred cup of water rather than a spinning record. That randomized motion is not merely disorder. It is a form of stability after violence, the way a shaken box of stones eventually settles into a new arrangement. The galaxy is not disintegrating. It is relaxing into an equilibrium that reflects its history. And this brings us to the deeper question, the one that feels less like astronomy and more like a mirror held up to the human mind. Is complexity the inevitable price of scale? In many ways, yes, but not as a punishment, more as a consequence of contact. The bigger you become in a crowded universe, the more you interact, the more you incorporate, the more you must reconcile competing motions and memories. Scale invites entanglement. Scale invites collisions. Scale invites the accumulation of exceptions. A small galaxy might live a relatively quiet life on the outskirts of a cluster, retaining a clean shape. A giant at the center becomes a collector, and collectors rarely own only one era. They own many eras stacked together. There is also a quiet, invisible architect here, dark matter. The largest galaxies sit inside enormous dark matter halos, structures that extend far beyond what the eye can see. These halos are like gravitational landscapes, drawing in smaller halos and the galaxies embedded within them. The visible galaxy is only the bright foam on the surface of a deeper sea. As that sea grows through cosmic time, it pulls in more material, and with it, more complexity. The visible chaos, then, is partly the glow of a much larger, unseen framework that has been assembling since the early universe. When you consider that, the disorder starts to feel less like confusion and more like evidence, as if the galaxy is saying, quietly, I did not become this by accident. I became this by history. Stephen Hawking once reminded us, the universe doesn't allow perfection. Taken literally, it is a scientific truth about entropy, about fluctuations, about the fact that nature prefers processes over ideals. Taken emotionally, it is also a kind of comfort. Because if the largest galaxies are complicated, scarred, and asymmetrical, then complexity is not a flaw. It is what growth looks like when it is real. It is what survival looks like when it has lasted for billions of years. And it suggests a strange kind of unity between the cosmic and the personal, not in a mystical sense that claims answers, but in a reflective sense that invites questions. We, too, become more complex with time. We carry mergers in our lives, collisions of experiences, losses, relationships, changes of direction, and we do not emerge as simpler beings. We emerge as layered beings. So perhaps the most educational gift these galaxies offer is not only a lesson in astrophysics, but a lesson in perspective. They teach us that scale is not just more. It is more history. It is more interaction. It is more consequence. The giant galaxies look chaotic because they are honest archives. They do not hide what happened to them. They display it in their halos, their stellar populations, their scattered globular clusters, their disturbed kinematics, and the quiet, heavy presence of central black holes that may themselves be the results of long-ago mergers. To understand them is to accept that the universe is not a museum of pristine objects. It is a theater of processes. And that thought leads us forward, naturally, into the next breath of the story. Because once you accept that the largest galaxies are complicated for reasons that are both physical and inevitable, another question rises like a tide. If chaos is the signature of growth, and if scale is written in collisions, then what does it mean to call any galaxy the largest? Are we seeing a final form, or just a moment in an ongoing assembly? Are there giants still forming beyond our current reach, in regions we have not mapped, under conditions we have not yet imagined? The universe has a way of making our superlatives feel temporary. So as we move on, keep that feeling close, the sense that largest may be less a crown and more a snapshot, because the next chapter is waiting in the dark, and it begins with a quiet realization. The moment we think we have found the ultimate giant, the cosmos may already be building something even bigger, somewhere beyond the edge of our present knowing. Have you ever wondered what it really means to say a galaxy is ancient? Not as a poetic adjective, but as a measurable fact written into the cold arithmetic of light and distance. Because the moment we ask how long it takes a truly colossal galaxy to form, we step onto a threshold where time stops behaving like a calendar and becomes something closer to geology, to the slow pressure that turns dust into stone and silence into structure. A giant galaxy is not built in an afternoon of cosmic fireworks. It is assembled in chapters, sometimes over 10 billion years or more, through the patient accrual of stars, the swallowing of smaller neighbors, the settling of dark matter halos like invisible scaffolding, and the long cooling of gas that once glowed as brightly as a newborn universe. And even that estimate, even that staggering span, is only a guideline. Because formation is not a single event with a neat beginning and end. It is a process that overlaps itself, a story told in layers, where the first stars can ignite early, while the final shape continues to change long after the first light has already escaped into space. Now comes the turn that always catches people, the twist hidden in plain sight. When you look at the immense size of one of these galaxies, you are not only seeing a place, you are seeing a time. You are watching the past, not metaphorically, but literally, because light is a messenger that never arrives on time. A distant giant may be so far away that its glow began its journey toward your eyes before the earth had forests, before mammals took their first tentative steps, before our sun was even born. This is why astronomy feels like a kind of disciplined longing. We point instruments at the sky and receive ancient news, delayed by the enormous corridors of space. The larger the scale you contemplate, the deeper you sink into time. A galaxy's diameter might be measured in millions of light years, but what that really means is millions of years of travel for a photon, millions of years of separation between an event and your awareness of it. And so, when you feel that sudden vertigo at the thought of size, it is not only size pressing on your mind, it is time pressing too. Because the two are braided together like strands of the same rope. This is where the idea of cosmic memory quietly enters, not as a mystical claim, but as a legitimate way to speak about what evidence actually is. If memory, in human terms, is information preserved through time, then the universe is lavish with memory. It stores its past in background radiation, in elemental abundances, in the motion of galaxies inside clusters, in the faint tidal streams that arc like ghost rivers around massive hosts. It stores its past in the scars of mergers, in the swollen halos of stars that do not belong to any single tidy disk, in the silent dominance of dark matter whose gravity shaped everything long before the first atom cooled enough to hold an electron. "We are a way for the cosmos to know itself," Carl Sagan once said, and the line endures because it carries a double truth. It honors human consciousness, and it also hints that what we call knowing begins with what the cosmos has already preserved. We do not invent these stories out of imagination alone. We read them, slowly, from the sky's archive. Consider a simple example that makes the scale emotional rather than abstract. Think of a cathedral built over centuries, stone set upon stone by hands that never lived to see the final spire completed. One generation lays foundations, another raises walls, another adds stained glass, another repairs what weather has wounded. The building is not a single act of creation, it is continuity. A giant galaxy is like that, except the builders are gravity and time, and the stones are star systems. And the renovations are collisions that would look like apocalypse if you could watch them up close. When two galaxies merge, it is not a clean, cinematic impact. It is a slow interpenetration, a long dance of tides and distortions. Stars mostly slip past one another, because space is so empty. But gravity reshapes everything, pulling out long, luminous tails, compressing gas into new bursts of star formation, feeding central black holes, and gradually settling the remnant into a larger, rounder, more massive structure. To say this galaxy formed is to compress that cathedral-like patience into a single sentence, and the sentence cannot hold it. The truth spills out. The truth is that formation is the ongoing conversation between matter and time. And here is a second example, one that brings the question back to your own body. Imagine looking at an old tree whose trunk is so wide you cannot wrap your arms around it. You might feel its age in the roughness of its bark, in the way its roots buckle the ground, in the quiet authority of its presence. But the tree does not remember its first spring in a human way. Its memory is written in rings, in layered grain, in the chemistry of its wood, in scars from lightning and drought. A giant galaxy is the same kind of entity on a different scale. Its rings are stellar populations of different ages. Its scars are streams of stars left behind by swallowed companions. Its chemistry is the record of how many generations of stars have lived and died inside it, enriching its gas with heavier elements, turning the universe from near pure hydrogen and helium into a place where planets, oceans, and eventually minds can appear. In that sense, the size of a massive galaxy is not merely a measurement. It is a biography. It is time made visible. This is why the question, how many billions of years does it take, is both scientific and strangely personal. In many cases, the earliest stages of a massive galaxy begin in the young universe, when matter was denser and gravity could gather it more quickly. Some giant ellipticals, especially those at the hearts of galaxy clusters, may have formed much of their stellar mass early, then continued growing through mergers for billions of years afterward. Their cores can be ancient, their outskirts younger in the sense that they were assembled later. The galaxy becomes a layered thing, like a memory palace built room by room. When you look at it now, you are looking at a structure that has been under construction for most of cosmic history. And because the universe itself is about 13.8 billion years old, even the oldest galaxies are not older than time's own beginning in our current story, which makes their age feel like a boundary stone in the mind. We reach it, and we touch the limits of what long can mean. At this point, it is natural to ask whether time is merely a backdrop, or whether time is the true architect, the unseen designer shaping everything from the inside. Time is what prevents everything from happening at once. John Archibald Wheeler famously remarked. And the genius of the line is that it sounds playful until you realize it describes the entire logic of structure. Without time, there is no sequence, no accumulation, no evolution, no gradual refinement. A giant galaxy exists precisely because the universe did not rush. It allowed matter to cool, to clump, to fall, to ignite, to die, to recycle. It allowed complexity to emerge through repetition. So, if time is the architect, then galaxies are its monuments, and we are something even more delicate, perhaps like the candlelight that flickers inside those monuments, briefly illuminating them from within. So, where do we stand in this blueprint? We are not outside it, looking in. We are inside it, made from its materials. The calcium in your bones, the iron in your blood, the oxygen you breathe. These are not generic substances. They are products of stellar lifetimes and stellar deaths, minted in nuclear furnaces, scattered by supernovae, and gathered again into new stars and planets. The blueprint includes you, not as an afterthought, but as a late chapter in a long narrative of transformation. And that realization carries a quiet educational power. It does not demand that you believe in anything beyond evidence. It simply invites you to see your life within a larger continuity. A giant galaxy teaches, without preaching, that greatness is often the result of patience, that complexity is usually the consequence of time given room to work, that the universe becomes more interesting the longer it lives. When you feel overwhelmed by the numbers, by the billions of years and the millions of light years, remember that the feeling itself is part of the lesson. R is not ignorance. R is recognition. It is your mind encountering a scale beyond its everyday training and deciding, for a moment, not to reduce it into something small and comfortable. You do not need to chase sensationalism to feel wonder. You only need to look honestly at what the cosmos is already doing. The giant galaxy is out there, enormous and indifferent, yet quietly generous, because it offers us perspective. It shows us that our arguments, our anxieties, our hurried days are not the whole story of reality. It shows us that the past is not gone. It is still arriving, photon by photon, into the present. And as we move forward from this thought, let the next question form naturally, like a door opening into a darker corridor. If a galaxy's vastness is time made visible, if its size is the signature of billions of years of construction, then what happens when big no longer even feels like a useful word? What do we do when language itself starts to fail, and the universe remains, calmly, impossibly immense? What happens to the human ego when it stands beside structures so vast that our language begins to fail? Not the practiced ego of job titles and opinions, but the deeper, quieter ego that whispers, I am the center, I am the measure, I am the story. The first time you truly confront cosmic scale, something delicate cracks. It is not humiliation. It is not despair. It is a loosening, like a fist unclenching after years of tension. You can feel it in the body before you can explain it in words. That subtle surrender when the mind realizes it cannot hold the whole sky in its hands. And yet curiosity pulls us forward, because the universe does not merely dwarf us, it invites us. It invites us to notice the difference between importance and magnitude, between meaning and size. It invites us to trade the brittle comfort of being large in our own story for the steadier dignity of being part of a greater one. As Carl Sagan once said, somewhere, something incredible is waiting to be known. The line lands like a lantern in a dark hallway. It does not tell you that you are nothing. It tells you that you are early. It tells you that wonder is not a weakness. It is the beginning of intelligence. Consider what it means, even in a simplified picture, to set the human timescale next to the universe's. A lifetime feels long from the inside. It holds heartbreak and recovery, childhood and aging, births and funerals, mornings that repeat until suddenly they do not. But then you remember that light, the fastest traveler we know, needs years to cross the distances between stars, and millions of years to cross the breadth of a large galaxy. Your private calendar begins to look like a single page torn from a library that never ends. That recognition can be jarring at first, because the ego craves a stage that fits the performance. And cosmic scale offers the opposite, a stage so immense the performance becomes a whisper. But here is the surprising twist. The point most people miss until they sit with it long enough. The whisper matters more, not less. In a world where everything is loud, being small can be a kind of freedom. If the universe does not revolve around your anxieties, then your anxieties do not deserve to revolve around you. This is why understanding the scale of the cosmos so often leads to humility rather than hopelessness. Hopelessness comes when we believe we are trapped in meaninglessness. Humility arrives when we realize meaning was never about being the biggest thing in the room. In fact, the most enduring meaning we know of is rarely associated with size. Love is not large in kilometers. Compassion is not measured in light years. Integrity has no mass. The universe can be incomprehensibly vast and still leave room for the quiet human act of choosing kindness over cruelty, patience over panic, attention over distraction. Humility is not the collapse of value, it is value put back in its proper place. The cosmos does not erase us, it repositions us, and in that new position we can finally see the difference between urgency and importance. There is an old tension inside the scientific mind, a tension between our desire to know and our need to be comforted by what we know. We want reality to be grand, but not so grand that it makes us feel irrelevant. We want mystery, but not so much mystery that it makes us feel lost. And so we walk a narrow ridge. On one side is the illusion of human centrality, warm but fragile. On the other is the abyss of nihilism, cold and unnecessary. The strange gift of cosmic perspective is that it offers a third path, reverence without delusion, awe without self-deception, a sense of belonging that does not require dominance. Neil deGrasse Tyson captures this pivot with a line that is both simple and quietly radical. The universe is under no obligation to make sense to you. At first it sounds like a rebuke, but if you let it settle, it becomes a relief. It means the universe is not a puzzle designed to flatter our brains. It is not a classroom tailored to our attention span. It is something older and stranger and wider than our preferences. And because it is not obligated to cater to us, we are free to approach it with honest humility. We can admit confusion without shame. We can ask questions without needing immediate control. We can learn without pretending to be masters. And when you approach the cosmos this way, something else happens. You begin to see your daily life differently. Because daily life is built on a particular kind of illusion. The illusion that what is close is what is real. Your inbox feels real. The argument from yesterday feels real. The deadline, the traffic, the minor slights and small victories, they expand to fill the entire field of view. But cosmic scale is like stepping back from a painting you've been pressing your face against. Suddenly the brushstrokes stop being the whole story. You can still care about your life, but you care with more spaciousness. You care without drowning. Imagine a simple example. You are lying on your back in a dark field, far from city lights. The grass is cool under your shoulders. The air has that faint mineral smell that comes after the sun has fully gone. Above you, the stars are not a decoration. They are a depth. You pick out a constellation you learned as a child, but then the thought arrives, uninvited and precise. Many of those points are not stars in the way you were taught to imagine. Some are systems. Some are far enough that the light left before certain civilizations on Earth ever existed. And you realize that the sky is not just above you, it is behind you in time. In that moment, whatever you were obsessing over earlier today loosens its grip. Not because it stops mattering, but because it is no longer the only thing that matters. The ego, which thrives on narrowness, begins to soften. And in that softness, you may feel something like gratitude, not directed at any one thing, but at the sheer fact of being here to witness any of it. Now bring that feeling into a second example, more ordinary, almost mundane. Picture yourself holding a cup of tea or coffee in the early morning, before the world fully wakes. The kitchen is quiet. The window is still dark or just beginning to grey. You lift the cup and feel warmth through ceramic, a small sun between your palms. For a moment you remember that every atom in your body was forged in ancient stellar furnaces, that the calcium in your bones and the iron in your blood were born in processes far beyond anything a human hand can build. You are not separate from the cosmos. You are the cosmos arranged into a person, briefly able to notice itself. And the smallness of your cup, the simplicity of the moment, does not shrink under that knowledge. It becomes sacred in a different way. The everyday becomes luminous, because it is no longer just everyday. It is the universe, up close. This is the educational value hidden inside cosmic scale. It teaches perspective, not as a slogan, but as an experience. It teaches that there are levels of reality, and that your mind can learn to move between them. It teaches you to zoom out when the inner world becomes claustrophobic, and to zoom back in when the outer world feels too cold. It teaches balance. It teaches that you can live with mystery without turning it into fear. And it teaches, perhaps most importantly, that the world does not end at the boundary of your stress. Which brings us naturally to the final question, the one that begins to appear once the ego has quieted and the perspective has widened. Is science, at its deepest level, teaching us how to slow down? Not in the sense of abandoning ambition or progress, but in the sense of refining attention. The night sky is not something you consume quickly. You cannot skim it like headlines. You must sit with it. You must let your eyes adapt. You must let patience do its quiet work. The universe rewards the slower mind, the mind willing to look longer than is comfortable, to wait for meaning to emerge rather than forcing it. Science is often portrayed as a relentless machine, always accelerating, always chasing the next result. But the heart of science is not speed. The heart of science is listening. It is the discipline of not answering too quickly. It is the humility of letting evidence lead rather than ego. In that way, the scientific mindset and the meditative mindset share a subtle kinship. Both ask you to notice what is there, not what you wish were there. Both ask you to hold uncertainty without panic. Both train you to watch carefully, and in watching carefully, to become quieter. And so we return to where we began, with the human ego standing in the shadow of immense cosmic architecture. The ego wants to be the main character, but the universe does not seem to be built around main characters. It seems to be built around processes, relationships, and time. The great galaxies collide and merge, not out of malice, but out of gravity's patient choreography. Stars are born, burn, and fade, not as tragedies, but as transformations. Even the largest structures we can name are temporary, drifting toward futures we can barely imagine. And in that vastness, our lives are brief, yes, but also astonishing. Because we are not merely alive, we are aware. We are able to ask the question at all. If cosmic scale leaves you with anything, let it be this. Humility is not the opposite of significance. Humility is the doorway to a deeper significance, one that does not depend on being the center. And if the sky makes you feel small, perhaps it is not asking you to shrink. Perhaps it is asking you to expand, to widen your sense of belonging beyond the borders of the self, to live a little more gently, a little more slowly, and with a little more wonder than you did yesterday. Because in the end, the most extraordinary fact may not be how big the universe is, but that it has produced, in a quiet corner of one ordinary galaxy, a mind capable of looking up and feeling awe. What do you think that awe is for? What if the largest galaxy we can name today is only the biggest silhouette our lantern happens to touch in a cavern that has no walls? IC 1101 sits in our catalogues like a monument, a vast city of stars whose scale strains language, and yet it may say less about the universe's true limits than it says about the limits of our sight. Because every time we call something the biggest, we are really announcing the edge of a method, the boundary of an instrument, the end of a particular kind of patience. Astronomers do not look out into a clear infinity. They look through filters, through time, through dust, through the stubborn fact that light has a speed and the universe has an age. The cosmos is not only large, it is also delayed. We are always watching an ancient film, and the further we look, the earlier the frames become, until the story fades into a glow that does not show galaxies at all. In that sense, IC 1101 might be less a final answer and more a signpost saying, "Here is what the universe allows you to notice, for now." It is worth pausing on the humility embedded in that phrase, "for now." The most honest science is never a victory lap. It is a candle carried forward, steady hands, careful steps, knowing the next gust of discovery could redraw the entire room. Equipped with his 5 senses, man explores the universe around him and calls the adventure science. Edwin Hubble once wrote, and there is something quietly tender in the word adventure. An adventure is not a conquest, it is a willingness to be surprised. It is an agreement with mystery that we will keep walking even when the map ends. So when we ask whether IC 1101 is the ultimate limit, we are really asking a deeper question. How many galaxies exist beyond our current ability to observe? The simplest answer is, we do not know, and the most important part of that answer is why. Our observable universe is not a fence built by reality. It is a horizon built by time. There are regions so distant that their light has not had enough time to reach us since the universe began expanding, and there are regions whose light may never reach us at all, because space itself is stretching between us faster than photons can cross the widening gulf. The universe could be far larger than the portion we can ever see, not because it is hiding, but because it is old in one direction and still unfolding in another. To make this feel real, Imagine standing on a beach at night with a small flashlight. The ocean is vast, but your beam touches only a narrow ribbon of waves. You might shine it and catch a passing ship, and for a moment that ship becomes the furthest thing you can confirm. Yet the ocean does not end where your light fades. The darkness is not emptiness, it is simply unlit. IC 1101 can be like that ship on the horizon, astonishing in its scale, yes, but also a reminder that the darkness beyond is not a conclusion. It is a question asked by physics itself. And then comes the turning point, the moment technology widens our lantern. What happens when our instruments expand our vision one more time? History offers a quiet answer. The universe will not merely add details, it will change the story. When larger telescopes arrived, the Milky Way stopped being the universe and became one galaxy among billions. When detectors improved, invisible light revealed invisible structures, hot gas, dark lanes of dust, the faint scaffolding of matter on cosmic scales. Each leap does not only increase what we can see, it changes what we think seeing is. Here is another image to hold in your mind. Picture walking through a cathedral with stained glass windows, but you are allowed to view it only through a keyhole. You might decide the whole building is made of red and blue shards, because that is all the keyhole grants you. Then someone opens the door a little wider, and suddenly you notice the pillars, the arches, the symmetry, and the spaces where light falls without color. The cathedral did not change. You changed. Your access changed. Our telescopes are doors that open by degrees, and the universe has a habit of rewarding each wider opening with a more unsettling, more beautiful architecture than we expected. This is why the final question lands with such force. Is the universe always larger at the exact moment we think we understand it? In a sense, yes, because understanding is not a finish line, it is a moving shoreline. The more precisely we measure, the more clearly we see the fog that measurement cannot yet pierce. And that is not failure, it is the signature of a living inquiry. Carl Sagan once said, "Somewhere, something incredible is waiting to be known," and the power of that sentence is that it does not promise comfort. It promises discovery, which can be thrilling, disorienting, even a little holy. So perhaps IC 1101 is not the last giant. Perhaps it is simply the current face of vastness, the universe's way of teaching scale through a single, overwhelming example. Behind it may lie other galaxies even larger, or stranger, or more diffuse, structures we have not yet learned how to recognize, because recognition itself is a skill that evolves. And if that is true, then the real educational gift here is not a number, not a record holder, not a trophy for the biggest thing we can name. The gift is a perspective. We live inside a reality that is not obligated to fit inside our minds. And yet, step by careful step, it allows itself to be known. And as we move forward, as the next generation of telescopes widens the door again, the question becomes less about whether the universe has an end, and more about whether our curiosity does. If the cosmos keeps expanding beyond our certainty, will we meet that expansion with fear, or with the quiet steadiness of an explorer who understands that wonder is not a problem to solve, but a practice to return to? As we come to the end of this journey, what remains is not a single answer, but a shift in perspective. IC 1101, often described as the largest galaxy we know, is less a final destination and more a mirror held up to our understanding. It shows us how far human curiosity has carried us, and just as importantly, how much farther reality extends beyond the edges of our current vision. Every time we label something as the biggest, the furthest, or the ultimate, we are quietly revealing the boundary of our tools, our methods, and our moment in history. The deeper lesson hidden in this story is not about size alone, it is about humility. The universe does not shrink to fit our expectations, nor does it rush to explain itself in terms that feel comfortable. Instead, it expands patiently, inviting us to grow alongside it. Each improvement in technology, each clearer observation, does not close the book on cosmic mystery, it opens a thicker one. What once felt complete becomes provisional. What once felt certain becomes a question again, and in that cycle, science remains alive. There is also a gentler lesson here, one that reaches beyond astronomy. When we recognize how vast the cosmos truly is, our place within it does not become meaningless, it becomes precious. Against such enormous scales of space and time, the act of wondering, learning, and seeking understanding becomes a profoundly human achievement. We are small, yes, but we are aware, and that awareness is rare. So perhaps the greatest value of contemplating the largest galaxies is not the data they provide, but the mindset they cultivate. Patience, curiosity, respect for the unknown, an acceptance that understanding is always a process, never a finish line. Thank you for taking this journey with me. Thank you for lending your time, your attention, and your curiosity. If these questions stirred something in you, carry them forward. Keep wondering. And remember, the universe is always larger than our answers, but it always welcomes better questions.